Welcome back to the channel. Today we're going to be dealing with simultaneous equations. And before we get into simultaneous equations, I would like you to do something for me. So do share the videos with other students that are doing their Form 5, BJCE, IGSCE this year. Invite people to like the Facebook page, and also invite people to subscribe to my YouTube channel. I'm using the same name on both YouTube and Facebook, so that everyone who needs the revision and tutorials could access the videos, and a good number of you will be able to perform well this year. So let's start our session for today. So we are going to be dealing with simultaneous equations. So simultaneous equations are just a system of equations constrained by two variables, or rather, let's say it's just a system of equations. And for your purposes, with a certain number of unknowns. So I don't know, like the best way to define it to your level, but as simultaneous equations. Let me just give examples, and it would be easier that way, because the language I wanted to use may not be quite familiar with the most of you. So simultaneous equations, for you to be able to solve a simultaneous equation, you need to have the same number of equations as the variables or the unknowns that you have. For example, if you have two unknowns or variables, or let's just say x and y, you need two equations in x and y to be able to find the value of x and y. So this might not make a lot of sense for now. So let's just go into the examples, and the examples will clarify what we want to do. So today I'm going to be solving simultaneous equations using three techniques. The first one is by substitution. Then the second one is by elimination. And the third one is by graphing. So you can use these techniques. I mean, if you go further, other people use techniques like determinants, and other people go into matrices. So you can solve them, determinants, matrices, and just a host of other techniques. And for the intents and purposes of this video and for your level, we are going to be looking at substitution, elimination, and graphing. And sometimes you may not even be asked to graph these equations, but I'm going to show you that, you know what, you can use either substitution, elimination, or graphing, and you will still go to the same answer. So I have a couple of examples that we're going to be just breezing through today. So the first example is 2x plus y equals to 5, and we have x plus 3y being equal to 5 also. So we're going to solve this using those different techniques that I told you. So first, let's start solving this by substitution. If you're going to be solving this by substitution, we are going to choose either equation 1 or equation 2 and make one of the variables subject to the formula. So in equation 1, it will be easy to make y the subject of the formula because you just move the other value to the other side. And in equation 2, it will be easy to make x the subject of the formula. So let's just choose equation 1 and make y subject of the formula. So if we use equation 1, so we're going to have it's still 2x plus y equals to 5. So we want to move this 2x to the other side. So it's minus 2x minus 2x. Sorry for that. Then you're going to be left with y is equals to 5 minus 2x. So this would be very simple for you if you attended my other sessions and saw what we were doing in the other sessions. So the first step is that you make one of the variable subject of the formula. Then after doing that now, you substitute this into equation 2. So when you go to equation 2 is x plus 3y, this is equals to 5. So we're going to replace this y with that because the value of y is 5 minus 2x from equation 1. So we're going to replace this y with 5 minus 2x, and thus we're going to get rid of the y from the equation. So we're going to have x plus 3 times y. Y is what? 5 minus 2x. And this is equals to 5. And on doing that, you're going to just expand x, then 3 times 5, that is 15, minus 3 times 2, that is 6x, is equals to 5. Then what you're just going to do here is to collect like terms. This term and that term are like terms. So when you collect them, you're going to be left with minus 5x plus 15 is equals to 5. Then you subtract 15 this side and subtract 15 this side. So you're going to have minus 5x is equals to minus 10. Then you divide by minus 5 both sides. You divide by minus 5 both sides. And on doing that, that cancels that. Then x is going to be equals to 2. Then now after finding the value of x, we go back to that equation that we had, y is equals to 5 plus 5 minus 2x, y is equals to 5 minus 2x. And you substitute now the value of x, which is 2, into that equation. So you're going to take this and substitute it there. So you're going to have y is equals to 5 minus 2 times 2. And this gives you 5 minus 4, which is just equal to 1. So your x is going to be equals to 2, and your y is equals to 1. And that is your solution using substitution. And you can check that by substituting 2 and 1 into the equations that we had from the start. So now we're going to solve the same equation now, but by elimination. And let's see if we get the same answer. So now solving it by elimination, we have 2x plus y equals to 5. Then we have x plus 3y equals to 5. So now to solve this by elimination, we need to have the coefficient of x or y being the same value. So let's start by eliminating x. And for us to be able to eliminate x, so now x here is multiplied by 2. So it's multiplied by 2. Then x here is multiplied by 1. So for us to be able to have these to be the same, we are going to now take the same equation and multiply the bottom part by 1 and multiply the the upper part by 1 and the bottom part by 2. So in doing that, we're going to have 2x plus y equals to 5 times, so the whole thing, times 1, and we're going to have x plus 3y equals to 5. So the whole thing, we're going to multiply through it by 2. And what that gives us now is that 1 times 2x is just 2x, then plus y equals to 5. This equation doesn't change. Then the bottom one now becomes 2x plus 6y equals to 10. Then now when we have it like this, we can eliminate x by subtracting x. We're just subtracting the two equations. So 2x minus 2x, it gives you 0. Then y minus 6y, it gives you minus 5y. Then 5 minus 10, it gives you minus 5. Then minus 5y being equal to minus 5, we can just divide by minus 5 here and divide by minus 5 here. Then you get y is equals to 1, as in the first equation. Then after you do this, you can go back now to your substitution. You can choose either equation 1 or equation 2 to substitute into to get the value of x. So we're going to choose equation 2. So equation 2 is x plus 3y is equals to 5. Then on substituting y is equals to 1, this becomes x plus 3 times 1 equals to 5. Then this becomes x plus 3 is equals to 5. Then we subtract 3 here and subtract 3 here, then x is equals to 2. So your answer becomes x equals to 2, then y equals to 1. So now let's look at the first example. What did we have? X equals to 2, then y is equals to 1. Then we can also do the same thing by graphing. So graphing, I'm not going to draw the graph here, but I'm just going to put an image from my computer and show you what it would look like if you graph it. So this would be the image that we had. So this is the solution that we had. So this is the graph for that equation. And on this graph now, you realize that this point is 5. This would be just 4. Okay. Then this would be 3. This would be 2. And this would be 1. And this here would be 1. And that would be 2. And this lower equation here, this equation here is the equation of x plus 3y equals to 5. Then this equation here is the equation of 2x. Sorry for that. 2x plus y is equals to 5. And where these two lines intersect is that point there. It gives you your answer for x and y. So the x coordinate is 2 at that point. So x is equals to 2. Then the y coordinate at that point is 1. Y is equals to 1. So for you, since you have time and I don't have a camera to be able to take the whole drawing process, you can just do it yourself and see if you get the same answer. And what this tells you is that regardless of which method you use, you're going to get to the same answer. Here we used elimination, we got the same answer, and substitution, we got the same answer as what we got here. So this gives us confidence in maths and what we can be able to do through maths. So you've seen that it does work. So I'm going to take you through another example so that we could reinforce this. This would be example number 2. that is example number 2 now that we're going to be dealing with, which is x plus 2y is equals to 8, and we have 2x plus 3y equals to 14. So we're going to do it by substitution. So on substitution, we take this equation and we're going to make x subject of the formula on that equation. That is equation 1, and this is equation 2. And when we make x subject of the formula in that equation, we subtract 2y this side and subtract 2y this side. So x is now equal to 8 minus 2y. Then after we have this now, we take it back and substitute it in what? In equation number 2. So to substitute it in equation number 2, wherever we have x, we replace it with 8 minus 2y. So this gives us now 2 multiplying x, and the value of x is here, which is 8 minus 2y plus 3y is equals to 14. Then we can start expanding out. So 2 times 8 gives you 16. 2 times negative 2, that is minus 4y plus 3y is equals to 14. Then we collect the like terms. The like terms, these are our like terms here. So it was essential for you to attend the algebra class because you need to know this from algebra. So now we have 16 minus 4y plus 3y is going to give you minus y. This is equals to 14. So what we are going to do here is just subtract 16 both sides. So minus y is equals to minus 2. So the negatives cancel each other, then y is equals to just 2. Then we go back to the equation that we had earlier of 8, x is equals to 8 minus 2y. So x is now equals to 8 minus 2 times y, which is 2. So x is equals to 4 here. 8 minus 4, that is 4. So the system of solutions that we're going to have is x is equals to 4, then y is equals to 2. So this here would be your solution. So we can still do the same thing now by elimination. So doing the same thing by elimination, we're going to have x plus 2y. So that was substitution. So this one is elimination. Yeah, the one I did earlier was substitution. This one is elimination now. Is equals to 8. Then you have 2x plus 3y is equals to 14. So we do the same thing that we did earlier. So the factor here is 2. The factor there is 1. So what we're going to do is that we're going to multiply the whole of the equation at the top by the factor multiplying x at the bottom, which is 2. And we're going to multiply the whole thing at the bottom by the factor multiplying x at the top, which is 1. So on doing that, we're going to have 2 times x, that becomes 2x, then 2 times 2y, that becomes 4y, equals to 2 times 8, that is 16. And we're going to have this equation remain the same, because if you multiply this whole thing by 1, it still remains the same thing. So that becomes 2x plus 3y is equals to 14. Then what we're going to do is just subtract these two equations. And on subtracting, 2x minus 2x is just 0. Then 4y minus 3y is going to give you just y. Then 16 minus 14 is going to give you 2. So what this means now is your answer is y is equals to 2. Then you take this value of y is equals to 2. Then you can substitute it on either one of the equations that we have here to find your value of x. So let's choose equation number 1. So x plus 2y equals to 8. So x plus 2 times 2, so y is 2 here, then this is equals to 8. So what you get is x is equals to 8 then you subtract 4 here, subtract 4 here. So x is equals to 8 minus 4, and x is equals to just 4 on this question that we have here. You can compare with the other one. So it's still the same thing that we got here. So x equals to 4, y equals to 2. Then we can still do the same thing now. We can still compare with the results that we got from graphing. So I'd already graphed the functions before we started. So we have another graph here that I'm going to put here. So this is the graph that we have here. So same thing on the graph. Same thing on the graph as earlier on. This is the point of intersection here. At that point of intersection, the value of x here is 4, and the value of y is equals to 2 here. Then you have these two lines that are crossing at different points of the axis that you have here. So you just sort your way out after drawing the graphs, and when those two graphs intersect, that is going to be your solution. So your solution is x is equals to 4 and y is equals to 2. So that is that. And that is the same thing that we had in the other examples that we had above there. So I'm going to solve one last question using all the techniques that we have here, which is going to be question number 3. I think it's going to be sufficient for today so that I don't clog you with too much. So we are starting with substitution again here. So this is substitution. So we're going to start with substitution. 3x plus y is equals to 10. Is equals to 10. Then we have x minus y is equals to 2. Then using substitution, we're just going to choose equation number 2 because it looks simpler to substitute into. This is going to be our equation number 1. So on choosing that, we just have x is equals to 2 plus y, because from this equation you can just add y here and add y here and eliminate this y from that side. Then after doing that, you take this and substitute it into that equation so that you could get the value of your variable. So 3, so this becomes 3 multiplying x. X is what? This value here, 2 plus y. Then this plus y is equals to 10. So what we're going to do here is expand this. That becomes 3 times 2. That gives you 6 plus 3y plus y is equals to 10. Then you collect the like terms. So this becomes 6 plus 4y is equals to 10. Then you get rid of the 6 from this side by subtracting 6 both sides. Then you have 4y is equals to 4. Then you divide by 4 both sides. And upon dividing by 4 both sides, that cancels that. That becomes just 1 over 1. Sorry, there was a slight delay on my side. Y is equals to 1. So you have your y is equals to 1 there. Then you can just go back to the other equation that you had. That becomes x is equals to 2 plus y. 2 plus y. Then x is equals to 2 plus 1. Since y is equals to 1, then x here sorry, once more. Yeah, then you have x is equals to 3. So that is your solution. Now let's take a brief look at the graphical solution and end the video for today right here. I think this would be sufficient. I had done more examples, but I think this would be enough. So now this would be your graphical solution. And on your graphical solution, you can also still see this is 5 here. That is going to be 4. That is going to be 3, 2, and 1. And that is going to be 1. So what this is telling me is that they're intersecting here. So at that point, x is equals to 3 and y is equals to 1. And you can clearly see that all of these methods that we used, they still give you the same answer even though they are different. And I hope you enjoyed today's video. So like the video, share the video with your friends, encourage them to come and like the page and get more content, and also check the YouTube video, Sage Editorials. Yeah, thank you.